Switching between two media items without any audible or visual delay is called a gapless playback. In order to achieve this gapless playback, we need to understand what exactly happens when we play any video using Exoplayer. So in this video, we'll be understanding some Exoplayer internals, and we'll also try to implement a gapless playback with Exoplayer playlist and PreloadManager. So let's start. Everything starts with creating and setting your media item. After that, we call exoplayer.prepare, and both of these operations happens on the main thread. After that, Exoplayer internally switches to a playback thread and it starts the preparation of a media source. What is media source? So media source defines and provides a media to be played by an Exoplayer, and it has a two main responsibility. The first one is creating and updating your timeline. Second one, creating and providing media period in the given timeline. Okay, so my media source is creating a timeline and it also providing media period for a given timeline. But what exactly is the timeline? Let's try to understand that first. In video streaming, we have different types of media structure. We have a video on demand, we have video on demand with mid-roll ads, we have live stream with in-stream ads, we have playlist, which is basically a list of media item, and it can have video on demand or live stream in between at any index. So these are the some different types of media structures. And my timeline is an abstract class that represent information about this media structure using window and media periods. Okay, in picture it looks like this. So this is timeline for a video on demand with no ads. Here you can see I have a window which starts from a 0th position and it ends at the playback end. It signifies that this whole duration is seekable. Second important thing here is I have one default position marker which defines that my playback will start from this position only. So when I enter into this video, my playback will start from a 0th position. Okay, and last thing here is I have a media period. Media period is a simple continuous piece of media. Okay, let's try to understand media period with ads example. So this is the timeline for a video on demand with mid-roll ads. Here my window is same. It is starting from 0, it's ending at playback end, and so I can seek into the any part of this video. The only thing that is changed is my media period. Now my media period is not continuous. It has a two discontinuity. One discontinuity here, another discontinuity here. And why this discontinuity is added? Because there is one separate media source or separate piece of media added in between. Okay, so this is the formal definition of media period. Last example, this is the timeline for a live stream with limited availability. Here you can see I have a very limited window. My window is not starting from a 0th position. It means that in this live stream I cannot seek to 0 position. I can only seek in this window only. I can only go forward backward in this window only. Second important thing here is that my default playback position is not at 0. It is somewhere near to the live edge. Okay, and last thing, my media period is not finite. It is still growing because it is a live stream. My content is not ended. I still have to download the next chunk. So that's why my media period is not limited here. From all this, we understood that my timeline is important for representing all these different media structure. Okay, and Exoplayer get this information about the media structure by parsing the master manifest. So this is the HLS master manifest. Here you can see I have one period, 3 segments in period 1, and after that there is a discontinuity in between, and after that I have to add segments, and again there is a discontinuity, and at the end I again have main segments. Okay, so this master manifest basically represent this timeline, video on demand with mid-roll ads. So now that we understood, my media source creates a timeline to represent a different media structures by using window and media period. But in order to create this timeline, Exoplayer first needs to download the manifest, and in order to do that it creates one loader instance. So this loader instance takes care of downloading the manifest. Once this manifest is downloaded and my timeline is created, the next thing is track selection. So in our manifest we get all the available tracks information. For example, this is dash manifest. Here we have a dedicated tag to represent one media period. Media period contains a different represent which denotes the available tracks. So here it is a 720p SD track. Similarly, there can be 1080p, 4K, and some subtitle track as well, like English, Japanese, etc. So all this information will be passed to TrackSelector. Now, based on the device capabilities, my network capabilities, my user preference, track selector decide which specific track it should play. It creates a track selection object. This track selection object will be used to finally configure a media period. Okay, so at the end of this loop, we'll have a media period which understand which specific track it should play. It understand which specific track data it should download. Along with that, it also know which specific renderer it should create to decode that data. Okay, if you go into the manifest, here you can see there is a SD track, and along with that there is one special information called codecs, and it's saying that in order to decode the 720p stream it should use ABC decoder. Okay, so once this media period is finally configured, it understands that it should initialize ABC decoder. So this decoder initialization also happens along with downloading the data for that particular track. Next thing is we need to build a synchronization between downloading the data and rendering it. So that's why we have one separate component called a load controller. So what exactly load control does is it waits for the enough data to download. Once the enough data is downloaded, it signals the renderer that it should start decoding that data. And once the enough data is decoded, you get your first frame render callback. So that's how whole setup works. All these things happens when we play any video using Exoplayer. So from this flow we understood that in order to get a first frame, as soon as I enter into any media item, I should perform four preloading operations. The first one is preparing a media source, that is downloading manifest, parsing it and creating a timeline. Second one is performing track selection. Third one is downloading chunks for the selected track. And the last one is creating and enabling renderer and also rendering enough data for the first frame buffer. If we can perform all these preload operations, now all these four preload operations, we can achieve a gapless playback. So that's the complete theory, and now we'll look into some code implementation part. This is the first example, Exoplayer with no preloading. I'm creating Exoplayer instance, setting media item on it and calling prepare. And in order to switch to any new media item, I'll again call set media item and prepare. I'm not doing any preloading in this. Let's try to experience this implementation. I have this demo app. It contains some implementation for all the approaches that we are going to try in this video. And on the right hand side, I have charts to monitor all the network requests. Let's try to experience a short video playback with no preloading. So without preloading, each media item is taking approximately 2.5 to 3 seconds. Second example, Exoplayer playlist. Here I'm creating Exoplayer instance same as before, but the only thing is we are adding one new property called use lazy preparation, and we are setting this property as false. Because of this property, now Exoplayer will try to preload a media source. As soon as you add any media item into the Exoplayer, Exoplayer will immediately start preparing its media source. Okay. So once the Exoplayer instance is created, I'm creating a list of media item and adding those lists into the Exoplayer. And after that, I'm calling prepare. Once this happens, if I after that I can switch to any new media item using seek2 method, in which I just have to pass the index of that media item from the list and the starting position of that media item. Let's try to experience Exoplayer playlist. With Exoplayer playlist, there is some improvement in the video startup time. At the end, I'll show you all the numbers. But one important thing that is happened because of which we got this improvement is when we add any new media item into the Exoplayer playlist, it will start preloading its media source. Okay. So for example, right now we are at this asset Ocean Rock and we have played all these assets. Okay. If I add any new media source, my Exoplayer will immediately start preparing it. It will immediately download its manifest and keep it. Another optimization it does is if I switch to the playback end and if my current asset is completely downloaded, Exoplayer will start downloading the data of the next asset, which is waterfall. Okay. So at this position, I also have media source prepared for the next asset. Track selection is also completed for the next asset. And I also downloaded chunks for the next asset. So if I click on the next, I got video startup time below 500 milliseconds. So this is the optimization that Exoplayer playlist provides. For every new media item, it prepares its timeline by preparing a media source. And once the current item buffer is downloaded, it downloads the chunks of the next media item as well. Third example, Exoplayer playlist with preload manager. In order to create a preload manager, first we need target preload status control. This preload status control gives preload stage for each item in a playlist. So there are three types of preload stages. The first one is stage source, second stage tracks, and the third one is stage loaded. These preload stages are similar to the preload operations that we define. So my preload manager is taking care of all these three preload operations. So using this target preload status control, my preload manager is created. Using that, I'm also creating Exoplayer. After that, I need to create a media item playlist and set it on a preload manager and Exoplayer. First, I create a media item and add it into the preload manager. Then, for the same media item, I ask for a preload media source from a preload manager. And I take that preload media source and add it to the Exoplayer. Okay, so in Exoplayer, I'm not setting any dash or HLS media source. I'm setting a preload media source now. In some edge condition, this preload media source can be nullable. If you messed up with your index or maybe preloading is not supported for a given media item, in that case you will get a null from the preload manager. So you will have to fall back to adding regular media item into the Exoplayer. So preloading will not work for this fallback item. Once all the data is added into the Exoplayer and preload manager, we need to call exoplayer.prepare. And we also need to set current playing index on the preload manager and call invalidate. This invalidate will trigger all the preload operations for each items that we define based on the current playing index. Okay. And after that, if I want to switch to any new media item, I'll have to call seek2 and I'll also have to set a new index and I'll again have to call invalidate. Let's experience our final implementation Exoplay playlist with preload manager. So this is the decent experience that we can achieve with the Exoplay playlist and preload manager. From my perspective, this is the best experience considering that we are only using a single Exoplayer instance. But still, this playback is not a gapless playback. There is some visual interruption when we switch between the item. And the reason for that interruption is we don't have a renderer to render the first frame data of the next item. Okay. If we go into this table, we are still not performing the fourth preloading operation. We are still not initializing one more renderer to render a data of the next media item. But in the recent releases, in the Media 3 1.6.0, Exoplayer added experimental support for a secondary renderer. So experimental support for pre-warming decoders. Without pre-warming, the transition from one playlist item to the next may not be seamless in some cases, For example, we may need to switch codecs or decode some video frames to reach to the start position of a new media item. With pre-warming enabled, a secondary video renderer can start decoding a new media item earlier, giving near seamless transition. So in the recent releases, our fourth condition for gapless playback is also, in order to enable a secondary renderer support, we just need to create one renderer factory and enable experimental set enable media codec video renderer pre-warming to true. So right now, secondary renderer pre-warming is only supported for a video renderer. After that, we need to set this renderer factory on our preload manager. So now I have two renderers, primary and secondary. Primary is rendering the current playing asset. Secondary is rendering first frame of the next media asset. And when this item transition happens, when we switch from current to the next media item, my secondary renderer will become a primary and primary renderer will become a secondary. So that's how Exoplayer will try to reuse the two decoders. Let's look into the Perfetto traces report for all the approaches that we tried. For single player with no preloading, we consistently got 3 second to 2.5 second first frame time. This load item, this load demo 0 denotes the time between calling exoplayer.prepare and your first frame render callback. What exactly is happening in between? So first thing, we are creating media source on our main thread. Once media source is created, Exoplayer internally switches to the playback thread and it starts the media source preparation. During media source preparation, it starts downloading the manifest. So this load parsing loadable phrase denotes the manifest downloading task, and it's also happening on the loader thread. Next thing, once the manifest is downloaded and parsed, my Exoplayer does the track selection, which is also taking around 164 milliseconds, right? Once the track selection is completed, we start downloading data for that particular track, and it is also taking around 1 second, sorry, 1.9 second. Once the enough data is downloaded, my decoder initialization starts. So after selecting a track, my decoder is initialized and it took almost 176 milliseconds to initialize video and audio decoder. So this is also a heavy operation. And after decoder initialization, my first time was rendered. So because of all this operation, my first time was 3 seconds and 357 milliseconds. And this is happening for all the media items. After zeroth item, while loading first item, there is one optimization that Exoplayer is performing internally. It's not creating a new decoder. It is trying to reuse the decoder from zeroth item itself. So it is saving almost 100 and 200 millisecond on decoder initialization, right? But this decoder reuse is also not guaranteed. In between, you have if you have a different type of video item, let's say you switch between S264 to S265, then this decoder will be released and new decoder will be created, and that will again add up to your first time render time. With Exoplayer playlist, initial item took almost 3.5 seconds to load, similar to the Exoplayer with no preloading, but consecutive item were loaded with 1.5 second delay. Reason, because in Exoplayer playlist, we keep media source ready, and after landing on the item, we just download its chunks. So in this trace, the only operation that took time was loading this HLS media chunk. And when we loaded the enough data, we started decoding it, and after that we got our first frame. So overall, in Exoplayer playlist, we can estimate my video startup time is around 1.5 second to 2.5 second. Last one, Exoplayer playlist with PreloadManager. In this approach also, the zeroth item took almost 3.5 seconds, but after that all the consecutive items were loaded with less than 200 milliseconds. So this is 168 milliseconds, Next item took 169 millisecond, and next item took around 193 millisecond. Reason, we already have manifest, we already have data. Track selection is also completed. So the only thing that we do after landing on any item is decoding the data and rendering the first frame. Still, this is not completely appless, but I think with secondary renderer, this VST can again be reduced to less than 100. So overall, we gone through the Exoplayer internals. Based on the internals, we decide the preload operations that we should do to achieve a gapless playback. Then we look into some code and we also experience some Exoplayer implementation. Exoplayer with no preloading, Exoplayer playlist with PreloadManager. And at the end, we also gone through the Perfetto traces of all this implementation as well. Hey, hi everyone. So this is the first video on the channel. If you learn anything from this, please give a like and subscribe to the channel. Thank you.